Hello, I will be going over the very recent entrance exam, Wiskunde B, Math B of April 21st, 2023. The results just came out, and this could be a good exercise for the next one that will be held in July. Remember, don't use a graphic calculator. You cannot use it, so don't use it when preparing for it. And also remember there's a syllabus, which you also can find on the CCVW website. And I will refer to this syllable. I also have another video on this. Okay, question 1. I already worked it out, as you can see. Just to speed it up a little bit. And writing actually on these writing pads is not something I'm very good in. Okay, this is about an exponential function and a logarithmic function. It's given by the function f is given by 3 times e to the power 2x, which indeed is an exponential function. And we have this integral here from 0 to a of this function. And they asking for which value of a, so which value of this upper boundary this integral is equal to 72. So this is what we call a inkomertje in Dutch. Just to warm up the fingers and the brain. It's not so difficult. So what's the primitive of this function? Well, it's a e to the power 2x. But if you would apply the chain rule to differentiate this, you can pick up a factor 2, which you have to compensate for. So you divide by 2. And as always with this, just do the derivative to double check that you get the original function back. Then you need to evaluate this between a and 0. And then you say, okay, this has to be equal to 72. So at a, you get this term, and at 0, you get e to the power 0, which is 1. So you can then just multiply both sides of this equation by 3 over 2, and by 2 over 3, sorry. And then you get e to the power 2a is 49. And with this, you can safely take the natural logarithm on both sides. And you get 2a is log 49, which means that a is log 49 divided by 2. Question 1b. They say this is another function. This is actually a logarithmic function. And they state that it has 2 inflection points. So they tell us already. And they want to know what the x-coordinates are of these 2 inflection points. Remember, inflection points, definitely something that is coming back in, I would almost say, every exam. And inflection point means that the double derivative has to be 0. It's somewhere in the syllabus as well. And if this happens at points where the double or the second derivative, I should say, of the function is 0, that there could be a inflection point. It's not sufficient. You actually also have to prove that the double derivative is not only 0, but it also changes sign. So it's like the function changes from convex to concave, or from concave to convex, which are also 2 terms that are in the syllabus materials. However, if you can, the best way with these is just only to look where this second derivative is 0. And if you find, for example, in this case, that there are two of these points, you don't need to show anymore that indeed the second derivative changes sign, because it's already given that it has two inflection points. They just want to know the coordinates. So let's see how it goes. First, the step-by-step, calculate the first derivative. And for this, where is the function? You use that the derivative of log x is 1 over x and apply the chain rule. For the second derivative, you just use the quotient rules for derivation, differentiation, sorry. And so doing that, combine some of the terms. You get this expression here. And then we set this equal to 0, which means that the numerator has to be 0. 2x squared plus 6 is equal to 0. And this denominator cannot be equal to 0. So that's kind of something we have to check later. Okay, this is some simple manipulation to find that x squared is 3. Remember, for these kind of power equations with an even power, you get always two solutions. So in this case, x is plus or minus the square root of 3. So is there anything on the domain here? No, this is all fine. The x squared plus 3 is all positive here. And this is also not equal to 0. And again, since they already mentioned there are two inflection points, we don't need to further study whether or not around these two x's the second derivative will change sign or not. Okay, moving on to C. Compute exactly the maximum value of hx of this function h given here. The derivative can be found by just using the derivative of product functions and a product of two functions. Since there's a square root here, it is actually a little bit cumbersome because you get a square root in the denominator. But so just slowly write it out. Now since we need to compute the maximum value, we have to set it, the derivative equal to 0, which means that this plus this is equal to 0. We can bring one to the other side and just use the cross product of two quotients. Something like if A by B is C divided by D, that means that AD is equal to BC, but both B and D cannot be equal to 0. So B is not equal to 0, D. So, and again, that is something we need to keep on checking as we go. We get some manipulation. You get a secondary equation, x squared minus x minus 2 is 0, which we can factorize. And then we find either x is minus 1 or 2, but 2 is not in the domain of function h, so we eliminate that. And again, we found that the derivative is 0 at x is -1. It doesn't mean that it's necessarily a maximum, uh, but they already say that it has a maximum value. They ask us to calculate it. So actually, I don't think you have to show here that it's a maximum value. If you need to show it, you just have to show that to the left and to the right of it, the derivative is changing sign, which is actually not too difficult in this case. And that is actually pretty easy to tell from this that x is a little bit smaller for -1, or h prime of x will have a different sign from a little bit to the right of x equal to -1. And they're actually not asking the x coordinate of the maximum, they're asking the value. So you need to substitute the value in h. So h of -1. And if you do that carefully, you get that it's equal to e. All right. Question 1 is doable, how to say. Let's see. We have a polynomial function given here, and in line L with equation y is x. And there is a bounded region enclosed by f and the line L. Okay. Now they ask us to compute the volume of the solid of revolution that's formed by rotating v around the x-axis. Okay. So we are going to rotate this thing around the x-axis. So if I can indicate it in this way. Well, this is also some standard stuff in the syllabus. So I have seen this in probably also most of the exams. So high probability that this is coming back and that this is something they want to check that you're familiar with. Okay. Now, here it's easy to make a mistake. Since when, say if you want to calculate the area of this without any rotation, then you would take the integral of the function f minus this line, so the function y is x, and do the integral. And you would be tempting here maybe to calculate, in this case, given the equation we know for these rotational volumes, to evaluate the integral from pi times 0 to a of function f minus x squared dx. But that actually would be wrong. In this case, you need to calculate the volume if you rotate f and subtract the volume if you rotate the line y is x. So this is actually the expression that you have to evaluate. And it's a little bit similar if you look at where this is coming from. If you look at a circle with the larger circle radius r2, smaller circle radius r1, if you want to find this area in between, you would actually calculate the area of circle 2 minus the area of circle 1. And you wouldn't calculate pi times r2 minus r1 squared. That's kind of a little bit of similar background. Instead of writing two integrals, actually writing it directly as one integral of f squared minus x squared, that's also fine, of course. Maybe this is even a little bit shorter. Anyway, that's not what I did here. The other part is we need to figure out what is this here, this upper limit. And we find this by setting this function f(x) equal to the line y is x. So you need to solve f of x is x, and that's the mass is given here. You will find that by some simple manipulation that x is either 0 or x is equal to 3. And x0 is actually our point here. So that's not the point we want to find. We want to find the upper limit. So x is equal to 3. So our upper limit here is a is equal to 3. And now we just need to calculate the whole thing. I calculated here first the first term. So integral of 0 to 3. Don't forget the pi here. Of minus x squared plus 4x squared. And this is just a slightly tedious calculation, just to work it out. Then evaluate it between the 3 and the 0. And there are quite a few terms here, so just do this slowly and steady. There's some ugly fractions in it, so just put them under the same denominator. But in the end, what you get is 33/5 pi. And then I want to subtract this second integral, which is pi, and then integral from 0 to 3 of x squared dx, which is simply 9 pi. Need to subtract it, so I get finally 21/3 pi. I've so far only seen questions where they ask these kind of things for rotation around the x-axis. If they ask about rotation around the y-axis, what you need to do is actually find the inverse of the function. You need to express instead of expressing y in terms of x, you need to express x in terms of y. So actually, you could, you would need to find from this function what x in terms of y is, and then you do the integral from, well, this y to the top y of that x expressed in y squared. Anyway, I have not seen this being asked, although it is in the syllabus, so it's better still to know that. Okay, there is a family of functions GA of x, x squared plus a. So if you remember, these are actually kind of vertical shifts, vertical translations in the function. And for which value of a, exactly the value of a for which the graphs f and GA are touching, well, here just when they ask about touching, remember two functions touching, that it means these functions have to intersect and the derivatives have to be equal. And just carefully work this out. So the first will tell you that x squared plus 4x is x squared plus a. And manipulate this a little bit. Actually, not much. Then the second is that these derivatives have to be equal. And you find that kind of independent of a is only happens in x equal to 1. So we already know that x has to be equal to 1. And then we can just substitute x equal to 1 in the first equation. And that can actually only happen when a is equal to 2. So that's the answer already. That's actually not too difficult. Perforations. I often see perforations, which are removable discontinuities. So these are things that could look something like, well, uh, you have a function with some open point here. And meaning that at this point means it is not defined. But if I go from below or from above, the limits have to be finite and the same. So if I reach to this from the left or the right, the limits should be the same. Okay, so let's apply that knowledge. Well, what does it mean to be not defined? Because if you look at this, if you look at this domain, the domain of H, it's everywhere defined except if this denominator here is 0. So the undefined points are x squared minus 9 is equal to 0, which means x is plus or minus 3. So only these points could possibly be perforations. So then we just need to study these 2 points. What happens if x goes to approaches 3? And just work out the limit of x goes from above to 3 of the function, and then kind of something that you can expect is that you can factorize the numerator. That's what you do here, so that some terms drop. And if that's actually not the case, then if you have not a cancellation of terms like that, then it would just mean that this function goes to infinity if x approaches minus 3 or 3. So anyway, just factorize 2x squared plus 5x minus 3. You just look at your minus 3 here and look at factors of 3, which is just 1 and 3. So just try out minus 1 times 3 or 1 times minus 3, and then see if it works out or not. So it's a little bit of trial and error. So you find 2x minus 1 times x plus 3, and no surprise, one of the terms drops with the factor in the denominator, and you get the limit of 2x minus 1 divided by x minus 3, which is not defined. And as a matter of fact, this the numerator will approach 2 times 3 minus 1, which is 5. The denominator will approach 1 over x minus 3, which goes to infinity. And in the same way, you can do this for x is equal to minus 3. Then you get almost the same, but since in this case x approaches from below 3, you get minus infinity. Actually, you don't even need to do this, because from this result here, you already see, hey, this is not finite. It's not a finite number if I approach 3, so it's not a perforation. So this is Maybe some extra work, but not required. Okay, then we look at what happens when x approaches -3. And then the same, you factorize it, and since we can then safely drop x plus 3 and x plus 3 here, because when x goes to -3, since we are x is not equal to -3, you're actually approaching it. So you can again drop this x plus 3 divided by x plus 3. And then if you substitute these, you get minus 7 over minus 6, which is 7 over 6. And it doesn't matter if you approach -3 from below, you get the same 7 over 6. And then we have showed that these two items here that we wanted to prove. And we conclude that the perforation is that x equal to -3 and y equals to 1 plus 1 over 6. All right, that's question 2. Question 3, the two circles and the 3 lines. We have this circle C1, C2, and 3 tangent lines that are in common to the circles. And in particular, K is one of the tangent lines, and K is the x-axis. So we know that the coordinates of these points are y equals to 0. The y coordinates are 0. And then they ask to show that the x-axis is indeed a tangent line to both circles. So let's go to the circles in the syllabus. Why is this not? Geometry in circles. Tangent line, point of tangency. A tangent line to a circle is perpendicular to the radius to the point of tangency. In other words, the slope of the tangent line times the slope of the radius is -1. Remember that? Two lines perpendicular means that the product of the slopes is -1, or one slope is the reciprocal of the, or negative the reciprocal of the other slope. Okay, so that means that the slope of the, I need to use a pen. That if I go from the center of the circles to this point of tangency, the tangent point, these have to be perpendicular to the tangent line K. So this has to be 90 degrees and this has to be 90 degrees. So yeah, what you then can do is find the expression of this line, which is actually a vertical line, if this is a tangent. Or in this case, it's way more straightforward just to find out this vector here, the vector from the circle center to the intersection point with the tangent line, the tangent point, and here as well, and find that they are perpendicular. Okay. So what is this tension point here? Let's first calculate these two, and that we just do by substituting y is x into the circle. It's basically finding the intersection of this line with the circle. So we have here our expressions, and for y here we just substitute 0, and you get x minus 4 squared is 0, and that's only one solution, 4, 0. So this point is 4, 0. Of course, if you would have found two solutions, there was something wrong. The tension line intersects the circle in only one point. And you do this for the second circle. So x minus 16 squared plus 0 minus 12 squared is 144. And these two drop, so you just find x minus 16 squared is 0. And then you find 16, 0 here. So let's look at the vector. We know the center point here is 4, 3. So what is the vector from 4, 3 to 4, 0? Well, trivially. Well, let's just work it out. I think that's done here. This vector, the vector that goes from points from one point to another point. Say I have a point A and a point B. This vector is simply B minus A. So the vector pointing from 4, 3 to 4, 0 is 4, 0 minus 4, 3, which is 3 minus 0 minus 3. And what's the direction of the x-axis? Well, of course, it's 1, 0. And take the inner product between the two, you find it's 0. So you've proven the two things. One, it's this line y is 0 is intersecting in one point, and the direction vector of this line is perpendicular to the radius of the circle. And then you do exactly the same for the showing that the vector from the center to the tension point here is perpendicular to the direction vector of the line. Okay, that's not too difficult. But remember all the stuff you learned about circles and generally about geometry, about vector representation of a line, since they allow you to easily tell things like the angles between two lines. And as a matter of fact, they are asking here, there is this line L, which actually is a tangent to both circles, but on exactly the same point. They're asking a vector representation of the line. Well, one thing that is in the materials about circles that tells you how to find very easily the line that is the line that goes through the intersections of two circles. And let me find that here. Computing the intersections of circles. Elimination of x squared plus y squared yields the equation of the lines through the intersections. So we need to
write the equation of the circles and eliminate x squared plus y squared. And that result will give me a expression for this line. Let's do that. This is the expression of circle 1, circle 2. You just work this out and then subtract. And what you will get is this expression here, 4x plus 3y minus 40 is 0. And that's a expression of a line. This is one of the kind of standard forms of a line that I think you're familiar with. And you can just actually write it. Oh, that's actually what I did here. So yeah, so this is the equation of the lines through the intersection, through the intersections. And in this case, it's only one intersection. But we're almost there, except that this is not a vector representation. So how to convert something like this into a vector representation? Well, first, just write it in the slope-intercept form, which is here. And you just isolate y here. You bring x and 40 to the right, and you get y is minus 4 over 3x plus 40 over 3. So the slope is minus 4 over 3. And if that's the slope, then the direction vector is 1 minus 4 over 3. Right? I do one step to the right, and I go minus 4 over 3 down. Right? That's what this number means. So that gives us immediately the direction vector. And then in order to get this representation, we will also need to know this one arbitrary point on the line. It doesn't have to be the intersection point, any point on the line. So just find something that is very simple. Let's say I set y equals to 0, then I find x has to be equal to 10. So the point 10, 0, that must be actually this point here, is on the line. So this point here. Then I have everything. Then I just say, okay, it has to be 10, 0 plus lambda 3 minus 4. Then question C, compute the sine of the angle between M and K. Yeah, this might be a little bit tough. And going back, this is I thought it's mentioned somewhere that if you have two tangent line, like line M here and line L, that they come together here in a, say, point P, and the bisector of this point P is actually the line that goes through the circles. So draw this line. Of course, I draw it very poorly here. Well, I drew it here better. The bisector is the line that goes through point P here and the circle centers. And you can also, since this is a bisector, this actually splits the angle between line M and K, what they're asking for, in two. So I just need to find the angle of the bisector with line K, and then double it to find the angle between M and K. Now, the angle of the bisector with K is just related to the slope of the bisector. So yeah, to kind of repeat this, line K and M are tensions of the circle 1 and circle 2 with an intersecting P. And so the line through P and the circle centers is the bisector of K and M. Okay, so and then the angle between M and K then is just 2 times alpha. And alpha we just find from the slope of the bisector. So what's the slope of the bisector? Well, there are several ways you can find it, but what I did here is just look at the fact that it goes to C1 and C2, and then I have a delta y here and a delta x, and then the slope is just that ratio. So I get delta y is 12 minus 3, and delta x is 16 minus 4. So it's 9 over 12, which is 3 over 4. And that's actually related to the tangent of alpha. So the tangent of alpha is 3 over 4. But they are asking the sine of 2 alpha. So that's actually another step here. The sine of 2 alpha is it's not something we directly know. We just know, actually we just realize that from alpha we can know both the tangent, the sine and cosine. So we need to express the sine of 2 alpha in, well, any sine, cosine, or tangent of the alpha. And then one formula that is just below also given here, sine 2 alpha is 2 sine alpha cosine alpha. But it's also 2 sine alpha times sine alpha divided by tangent alpha. And I know the tangent of alpha and the sine of alpha. Well, what's the sine of alpha? Well, that's the opposite divided by the hypotenuse of the triangle here, which is just 9, which is our delta y, and then the length of this thing is just 12 squared, using Pythagoras, 12 squared plus 9 squared and the square root. So the sine of alpha is 3 over 5. And then just substitute that here, then you get 24 over 25. You can also just directly calculate the cosine of alpha, right? The cosine of alpha would be the adjacent side here divided by the hypotenuse. So different ways, and you should get the same answer. And 3D, we have point A and point B on circle C1, and another point on the circle for which the angle ABC is 33 degrees. So let's just write down a circle and put the points on it just to visualize this. So I get 4, 0 here and 4, 6. And then I just put a point C here for which this angle here is about 33 degrees, right? So probably somewhere here, actually also could be here, doesn't matter. And then they want us to say what the angle alpha is, the angle BAC. And in many ways, when you see a circle with a triangle, think about Thales theory. It's also part of the syllabus. In particular, since one side of this triangle here is a diameter of the circle. And that says if you form a triangle like this with two chords as the other segments of the circle, then the angle formed here is 90 degrees. So we also know that the sum of angles of a triangle is 180 degrees. So we know that 30 degrees, which is the known angle here, plus 90 plus alpha has to be 180 degrees. So alpha has to be 57 degrees. So I think this is a tricky question probably for most, because there's some geometry involved. And just be sure you go through everything in this table. Don't skip it. Don't skip anything, since all of these can come back. Okay. Question 4. This exam actually was a little bit shorter than normal because I think they had some logistics issue and they had to make it 2.5 hours. But no exam is complete without a parametric equation. And you can make beautiful curves with this. In this case, the movement is given by a sine of 2t and a cosine of 3t. And the range, the interval is also given here. So at t is 0, we have x equal to 1. No, x equal to 0. X is equal to 0, and cosine 3 times 0 is 1. So we're sitting here. And then if you increase t a little bit, the sine will be positive. It will actually be greater than 0. The cosine will go down from 1. So basically we are going in this direction here. And then, well, we just follow the curve here. Okay, what are they asking again? Oh, okay, so certain moment it will intersect with the line y equal to x. Let me draw that. This is this line roughly. So yeah, it will intersect. Will intersect one more time. Intersect one more time. So a couple of times. And they want to know for which t this happens. Okay, that's, I think, doable. We just need to set y equal to x, right? That's what happens when you intersect with this line y is x. So it means the sine of 2t is cosine of 3t. And here we just convert a cosine into a sine by using the symmetry relations given. Again, these are all listed in the syllabus. Not here. Actually, this is something that's also useful here. And what again comes back is you need to be able to solve equation of this form. Sine x is sine a, cosine x is cosine a. And in the video I made on the syllabus, I also emphasized that before. But for the rest, there is a section on trigonometry here and symmetry relations. The symmetry relations are of the sign. And the particular one that we applied here is that cosine of x is sine x plus 1/2 pi. That's kind of again this horizontal translation. So we get this equation, sine 2t is sine 3t plus 1/2 pi. And this means that going back to, just rewrite it a little bit in the more simple form, sine x is sine a, means that x has to be a plus 2k pi, or x is pi minus a plus 2k pi. Remember this, I've seen this quite a few times. And also remember cosine x is cosine a. That's a little bit more simple. It's just x is plus or minus a plus 2k pi. These two you have to remember. Now just plug it in. Means 2t is 3t plus, just plug it in, and for a, the capital A here is 3t plus pi over 2. Plug it in, and you get, of course, two equations, right? The first is t is minus 1/2 pi minus 2k pi, and the second is t is 1/10 pi plus 2 over 5 k pi. And remember now, just systematically go over all the possible values of k. So start with 0, 1, 2, 3, until you're outside of the domain or the range for t. And so if you depleted that, then you try -1, -2, -3, etc. Okay, so k is 1, you find this, k is 0, you find t is minus 1/2 pi for the left solution. Then if you try k is equal to 1, then you're already outside of the range here. So then you don't even need to try 2, but then you try k is -1. Then substitute it here, you just find that then it's out of the range. And for the right branch here, because you have 2/5 k pi, you actually have more solutions that are still in this range. So k is 0 gives you 1 over 10 pi. K is 1 gives you 1/10 over pi plus 2/5 pi, which is 4 over 10. So you get 5 over 10, which is 1/2 pi, still in the range. So this is a solution. Then just do k equal to 2. And then if you do k equal to 3, then you're outside of the range. And go to k minus 1, minus 2, and then you find 2 more solutions. But when k is equal to -3, it's again outside of the range. Okay, so yeah, many solutions. And you just need to, probably what I should have done is just summarize the solutions here. So minus 1/2 pi, 1/10 pi, etc., etc. And they just need to have the values of t, so this is sufficient. Then in B, compute the angle at which the path of P intersects itself. Yeah, so you can see that in the origin, so the movement was like this. So at the origin here, it will move here, and then it will what's the next time? Just follow the curve. Here it will again pass the origin. So what is the angle that it intersects itself? So basically asking this angle here. Actually, it's not super clear to me. I think they just mean whatever is the smallest angle between these two. This angle here and this angle here. Just like the angle between two lines is defined as the smallest possible angle. So if I have a line here and a line here, then this is the angle defined as the angle between the lines. Now I'm sure that if you would have calculated this other angle, maybe you get something subtracted, but probably not too much. Maybe just 1 point or something. So yeah, what we need to do is so we have these tangents to the curve here, and if we find the slopes, the tangents, say of this tangent it's alpha 2 and of this tangent it's alpha 1, then the angle in between them is just the difference. It's just alpha 2 minus alpha 1. So let's calculate the slopes. Then there's this whole section on parametric functions. Slope of the tangent to the path in point P on a point on the curve is y prime divided by x prime. Y prime divided by x prime. Oh, and the other thing is, well, at what t do we need to evaluate it? When is it in the origin, right? So actually the first thing we need to do is find out for which t we are here. And that means that the sine of 2t, x has to be 0. And note, when x is 0, you could actually have some y being non-zero. So we also need to check that y is equal to 0. So let's first figure out where the x is 0. So sine 2t is 0. Well, when is sine of x 0? That means x is k pi. So 2t has to be equal to k pi. And inside this interval, so k can be any integer. So we start with k is 0. And if you, for k is 0, you get t is 0. But we saw already before when t is 0, actually y is 1. So that's not the origin. Then the next k is equal to 1. Then t is 1/2 pi, and then the cosine of 3 times 1/2 pi is cosine of 3 over 2 pi. That's 0. So t 1/2 pi at this t, it is in the origin. And you also find that at minus 1/2 pi, this point is in the origin. Now we just need to calculate y prime divided x prime for these two t's. And that's worked out here. It's definitely basic knowledge to find the derivatives. And then at half pi, you find the angle is minus 33.69. So yeah, that's this line here. So it has a negative slope. Remember, the slope is the angle with the positive x direction. That's also called the directional angle. And then at minus 1/2 pi, so that happened when t was negative, so trace back, it was here, then you find positive angle 33.69, which is kind of what you expect. And the angle in between is the difference, which is 67.38 degrees. And this is actually less than 90 degrees. So it is so-called acute angle. So that's in the end should be the answer. Now, if you find something that is larger than 90 degrees, then you should do 180 minus the angle. Then we have a point Q given by this parametric equation. And then they state that this is actually a parabola with an equation of the form y is ax squared plus bx plus c. Compute, now we need to compute the value of a, b, and c. So here we need to substitute these x and y's in this, and then figure out for which a, b, and c that always can be true. So that's what I've done here. We have substituted y and x, and then I manipulate it so that you write it in the form of a basically quadratic equation in cosine squared t. And then for this equation to be true, you need to, that can only be the case if the coefficients in front of these terms in the quadratic equation are 0. So then you find a, for the first a is equal to 2. You substitute a in the second, then you find b has to be equal to 0. You substitute your a and b in the constant term, then you find c is equal to a minus 4.